When I was young and I was still in school, I was really interested and I really enjoyed maths and physics. So when I was thinking what career I would like to follow when I grow up, I was thinking that engineering would be a good career for me because when I was working in the city, I was very fascinated by the buildings around in the city, the buildings that I was looking at, all the bridges. So I was really interested in a creative profession. So I thought that civil engineering would be a great career for me. So I was born and raised in Cyprus. And then I decided to move to the UK to study my degree. I studied Bachelor of Engineering at the University of Southampton in civil engineering. And then I went on to do my master's again in civil engineering at the University of Southampton. And when I graduated, out of all the modules that I was learning at university, the structural modules were the ones which fascinated me the most. So that's why I decided to go and pursue a career in structural engineering. I was working on a variety of projects, designing buildings at universities, offices, retail, residential, a bit of a mix really. And as I was getting more and more involved in projects, I was enjoying them even more. For the reason that at the beginning I started with doing a lot of structural calculations and designing the structure, deciding where the columns need to go. But then as I was getting more involved in projects, I was really enjoying the coordination aspect of it, the fact that we work together with architects, mechanical engineers, contractors, a big team of people that all work together to finalize the project and create an end product for the client. And that really interested me, and I was really enjoying that. Then I decided to pursue my chartership. So I was a trainee of the Institution of Civil Engineers. I was part of the training agreement of it. And I was going through the initial professional development process where I had to sign off different attributes such as technical, commercial, managerial, health and safety. And I recently sat my chartership exam this May, and I successfully passed it. And I think that's a really good opportunity to show that you're dedicated to your profession and you want to get at a better position in your career. And it's also a very good opportunity to learn about new people and professionals in the industry. Gives an opportunity to learn about what other people do and how you all get together and meet your peers from different disciplines. I'm also leading the S.T.E.M network at Transferable. The S.T.E.M network has currently 50 S.T.E.M ambassadors in the whole of Transferable UK. And all the Transferable S.T.E.M ambassadors, they volunteer, they go into schools, they go to career events, they speak to students and basically promote the profession and talk to all the students and inspire them to follow a career in the construction industry, which I think is really important. So in construction, you're not really limited by anything. You can be a designer in an office, doing your calculations and sketches. You can be a contractor out on site, building things and seeing your design on paper getting shape in real life. You can be managing projects, managing people. You can work with architects, work with mechanical engineers. There's such a variety of things you can do in construction. And at the end of the day, no product is the same. So the exciting thing about working in buildings is the fact that every building is completely different to the previous one you've worked on. And there's so many different constraints, so many different parameters that the different designers put together that, there's so many variety of things you can do. So, and I think it's really, really important. I'm also part of the Women's Engineering Society Young Members Board and Women in Property, and our job is to promote promote engineering, promote the profession, and bring together professionals from the different disciplines, and organize talks, events, presentations, and give them an opportunity to get together and exchange ideas and collaborate, which I think is really important in our industry. And at the end of the day, we provide these drawings to the contractor, who will read our drawings, interpret our drawings, and then build the project on site. So a typical day might consist of us doing structural calculations, producing our reports that will describe the building and discuss how the building works. We will go on site to look how the works are progressing, and if the contractor has any side queries that they would like us to answer from our drawings. It might consist of us doing structural inspections of existing buildings. So the general structural principles are the same, but it's the way you apply it which changes. So every condition is different, every building is different, every location is different. There will always be a new aspect of the design which will be different from the previous one you've done. So you have to use the knowledge you've gained through your work and experience and apply it in the new scenario, in the new challenge. Engineering is all about challenges. You have a challenge and you need to solve it. Our job as structural engineers is to design a building that will withstand all the forces around it, so all the forces which are imposed on the building. So generally, in most cases, you would have your permanent loads, which are the loads which are always there, and your variable loads, which are the loads which are not always there, such as the people walking around in the building, all the furniture, which they might change orientation. So these are your vertical loads, but you also get your horizontal loads. So in a building in the UK, you would usually design a building for the horizontal force from the wind. So that's the most typical horizontal load you design the building. But so recently I am involved in a project which is in a seismic region. So I've recently started learning about seismic design, and it's so much interesting and so much different than a typical building in the UK. So it's all the different forces that basically attack your building, and your job is to design it and make sure that it will still stand up even after the attack of all these forces. But it's interesting what you stated, because you also have to design for temperature. So a building in the UK will be subjected to the typical temperatures in the UK. But say if you design a building in Antarctica, for example, that and Ramboll are working on projects in Antarctica at the moment, you have to design them for the cold and extreme conditions down in Antarctica. So again, the way you approach the project is totally different, because it might be the same building in the UK, but if it's in a different region with extreme temperatures, extreme climatic conditions, extreme forces of nature, it will be a completely different design. So again, it's using your knowledge and the constraints that you have from the environment to design the building. And it's absolutely fascinating.
This is a direction that I'd like to test.
Yeah.
And then you prove it.
And then you prove it, absolutely.
And then you make sure it works.
Yes.
You know, or maybe it doesn't. You go, why? And then you go back again, and it's interesting. Absolutely.
And also when you see a drawing, you can quickly understand if it makes sense and if the sizes which are on there make sense more or less. And that's again is from your experience, without doing any numbers or any justified design from the codes of practice.
Yeah.
That's very important, a very important skill to have, to be able to get a drawing and say if it works or not.
And it's interesting that you say it's a feeling. It's almost like there is logic, there is rationality, there is reason, there is objective kind of ways of testing them. But initially, you also, because you're human, you have an emotional feeling.
Yes, absolutely.
It's like, does this feel right?
Does it feel right?
If it's well balanced, if it's calculated right, if it's worked out, I don't even need to run the numbers. I
know that it's working. And also there is, you can do all the calculations according to the course of practice to prove something, but at the end of the day, if it's not practical and it can't work, if you can't connect all the elements together, there is no much point to it really, because at the end of the day, someone needs to build it, so it needs to work from the geometry point of view as well, not just the numbers, but the practical sense of things.
There you go. Wow, yeah.
Yeah.